Right, so question 4 here. So on this question, if you look at the previous question, we're dealing with a horizontal circular path, but here we are dealing with a vertical circular path which is almost horizontal. Okay, so by almost we mean it's making a very small angle, okay, with the x. Okay, so it's not very different from question 3, okay, except here the only things that may change maybe are the equations. Okay, so because this one is vertical and it's making a small angle like that, I could make a rough sketch of this form. Okay, we have the centripetal force towards the center, and we also have the weight acting downwards, of course, and then the tension there is making a small angle with the horizontal. Okay, so this ball is being whirled around this circular path, and we can draw our triangle from which we can have sine theta equals mg over t and cos theta equals centripetal force over the tension. Okay, so we have two equations there which can be written: t sine theta equals mg as well as t cos theta equals mv squared over r. Okay, so we want to find the angle it makes. We are going to divide the two equations, equation 1 divided by equation 2, and we'll get tan theta giving us mgr over mv squared, and further giving us gr over v squared. Okay, so we have g, we know what the radius is, we know what the speed is, we have tan theta giving us 0.17. Okay, so to find the angle, therefore, we're going to get the inverse of the tangent, and we're going to find our angle as 9.65 degrees. Okay, so now to find the tension, we can use the first equation here: t sine theta equals the weight. We know what theta is, so we have t sine theta equals mg. We know what theta is, we just calculated there, and we know what mg is, therefore we can have the tension as mg over sine theta, giving us 26.4 newtons as our tension. Okay, so this is more like question 3. Okay, you just have to imagine it's vertical. Okay, not completely vertical, but it's making some angle with respect to the horizontal. So you sketch it however you can and draw the triangle to give you to show you how the forces are actually acting on this ball. Okay, all right, so we go to question 5. Question 5, we have a wheel with radius 25 centimeters and it has 8 spokes. Okay, so it's mounted on a fixed axle there, and then you shoot an arrow which is 20 centimeters long. Okay, so this arrow has to pass through the spokes without touching any of them. Okay, so we have to find the speed. Okay, we have to find the angular speed at which this wheel is rotating so that this arrow can pass through without touching any spoke. Okay, so we are going to consider the displacement first. We know that the angular speed is given by displacement over the time. So this time here is simply the time it takes the arrow to pass through without touching. Okay, so it's going through the space in between the displacement theta there, it's passing through. So we need to find the time it takes this spoke to pass without touching any the time it takes the arrow to pass without touching any of the spokes. Okay, so it has to pass through the space between two spokes. Okay, so we have 8 spokes, and one revolution of this wheel is giving us 360 degrees. So this 360 degrees is divided into 8 segments. So we're going to divide 360 by 8 to find the displacement covered between two spokes. Okay, so 360 over 8, we're getting 45 degrees. So meaning that each spoke is making 45 degrees with respect to the next one. Okay, so we have to convert this into radians here. We convert into radians. We have 45 degrees there, giving us pi over 4 radians. I'm sure you know how to convert by now. This shouldn't be a problem. You can try this on your own. I'm sure you have the notes. So 45 degrees is giving us pi over 4 radians. Okay, so this is the displacement between each spoke. Okay, so now that we know the displacement, we only need to find the time it takes the arrow to pass through from one side to the other without touching. Okay, so we know that the time taken is usually the distance over the speed. In this case, the distance is simply the length of the arrow. Okay, so we are going to have the length of the arrow divided by the speed with which it's moving. So we find our time here. T equals d over s, which is L over s. We have 0.2 over 6, and we get 0.033 seconds. Okay, so it takes 0.033 seconds for the arrow to pass without touching any of the spokes. Okay, so now that we know the time, we can find now the angular speed at which this wheel must rotate. Okay, so the angular speed here, we are saying it's going to be theta over the time. We know what theta is. It is pi over 4 radians, and the time is 0.033 seconds, giving us 23.79 radians per second. So this is the speed at which the wheel must be rotating in radians. Okay, so we simply convert that to revolutions per second. Again, this shouldn't be a problem. Okay, this shouldn't be a problem. Unit conversion. So when we convert that, we're going to have 3.79 revolutions per second. Okay, so try that. As you try, in case you are facing any challenges, again I emphasize, post your question in the group and I'm going to solve, or rather assist you. Yes, and yeah, I'll help you. Okay, so that's all. We wanted to find the speed at which the wheel should rotate so that ukakashuta kajaka arrow kapite without touching. Okay, yeah, without touching any of these box. Okay, so now question 6 here, we have this train traveling at that speed on a curve of radius 500 meters, and the distance between the rails is 1.5 meters. So we need to find how much the outer rail must be raised above the inner so that there may be no lateral thrust on the rails. Okay. Okay, so here we have rails, a train. Okay, it's more like a banked road, but in this case we have rails, one which is higher than the other, and they're both making a curve which can be assumed as a circular path of the given radius there. Okay, so if we consider the system, we are going to have a sketch of this nature. You can have a better sketch, of course, to visualize it more. To visualize it better, feel free to draw your own. Okay, so this is my sketch, and the forces are going to act. We have the weight there, and we also have the centripetal force. Okay, and of course the radius of this circular path. All right, so we have cos theta giving us mg over r, okay, which can also be written as r cos theta equals mg. Sin theta giving us centripetal force over r, or r sin theta equals centripetal force. So if we divide we divide the second one by the first, we are going to have tan theta giving us sin theta over cos that, and we remain with v squared over rg. We know what v is, okay? We know what v is. We convert this speed, okay? This 50 kilometers per hour, convert to meters per second. All right, after you convert that, you plug in here v squared, and we know what r is, we know what g is. We are going to have tan theta as 0.039. okay, so now we want to find the height to which the other rail should be raised, okay, so that there will be no thrust. So we have the first rail here, this one, okay, which is below, okay, and then we have the second rail which is raised to a height h, okay, and the distance between the two rails is d, which is 1.5 meters. Okay, so we have to find the height to which the other rail should be raised so that there will be no thrusting, right? So we have sin theta here giving us h over d, sin theta giving us h over d, and we're supposed to find the height in this case. So note that for very small values of theta, sin theta is equal to tan theta, okay? So this tan theta that we found earlier is going to be equal to sin theta in this case, which is this guy. Okay, so we are saying again here sin theta therefore equals tan theta, which is the value we found. This is the tan theta, okay, so that is tan theta there. Okay, so 0.039 equals h over d. We already know what d is. It's given as 1.5 meters, therefore we can have our height being equal to distance times that, and if we compute that, we'll find the answer in meters. Then converted to centimeters, it's giving you 6 centimeters. Okay, so this is the height to which the other rail must be raised to avoid the thrusting. Okay, all right, so again, go through. If you have any challenges, feel free to contact me on Telegram, even WhatsApp. Okay, so we have question 7 here. Satellite orbiting the Earth about 87 minutes if its orbital radius is 6,500 kilometers. Okay, so now we want to find the mass of the Earth. All right, so we have the Earth here with a capital M representing the mass, and we also have the satellite there, small letter m. So the Earth has got some gravitational field strength, as we know. Okay, so it has a tendency of pulling objects towards itself. Okay, and the satellite also is kept in this orbit by the centripetal force. Okay, so now we have two forces here that are going to be equal. Okay, the gravitational field strength of the Earth must equal the centripetal force acting on the satellite. Okay, that's the only way this satellite is going to be maintain its circular path. Okay, if any of these becomes less than the other, then the satellite may not maintain its circular path. Okay, so therefore we have gravitational force being equal to the centripetal force, And the gravitational force of the Earth with respect to the satellite is given as G, mass of Earth times mass of the satellite over r squared, r being the distance between the two, must equal centripetal force. Okay, this is our equation 1. Okay, then now the time it takes for this satellite to orbit the Earth, we know is given as t equals 2 pi r over the speed. Okay, t equals 2 pi r over the speed, or omega over v. So here what we need to eliminate in this equation is the speed. Okay, so in order for us to do that, we find first the expression for v in equation 1, and then after finding the expression for v, we're going to substitute that expression into equation 2. Okay, and then we make the mass of the Earth as our subject of the formula. Okay, so using equation 1, we are going to get v squared equals g capital M over r. Go through the steps. Equation 1 is here. Manipulate this equation and make v the subject. We are going to have v equals the square root of gm over r. Okay, so this is our v. So it's this v that we are going to substitute into equation 2. Okay, so we substitute that into equation 2, then we have the time being equal to 2 pi r over gm over the square root of gm over r. And if we solve that, find an expression for m, capital M, we're going to find the mass of the Earth being given as 4 pi squared r to the power 3 over t squared times g. Okay, we plug in the values that we have, we'll find the mass of the Earth as 5.97 times 10 to the 24 kilograms. All right, yeah, so just take your time, rewind these steps. Not clear, you can always ask. Okay, question 8. So question 8 here, we have this guy who is put in a drum, and the drum is actually rotating. So what's happening here is that this guy who is on the wall of this drum is held in position by forces. We have the friction force. Okay, so if this guy is to remain in that position there, okay, we have the weight pulling him down, but you can see that he's not going down. Okay, he's not slipping down, meaning that the friction is equal to his weight. Okay, and the friction in this case is acting upwards because the weight is acting downwards. So if this guy is not to slip downwards, then it means the friction holding him is equal to his weight. Okay, and since he is rotating along with the drum, his acceleration is towards the center. Okay, so again here we have a centripetal force acting on him. Okay, but notice that the surface, which is the drum here, is also exerting a force, which is the normal force. Okay, perpendicular to the friction force. Okay, so if he is to maintain his circular path, then we're saying that his normal force, or rather the normal force acting on him, must equal the centripetal force, okay, of this path. Okay, so therefore we have frictional force acting against gravity and is equal to mg. Also, the normal force is acting towards the center and therefore is equal to the centripetal force. Okay, so if this is the case, then we can have these two equations as frictional force equals mg and the normal force equals centripetal force, which is mv squared over r. Okay, so now we also know that frictional force is given by the coefficient multiplied by the normal force, from which we can obtain our coefficient as frictional force over the normal force. Okay, and we know that frictional force is mg, the normal force is the centripetal force. If we plug in, or rather substitute, we have mu equals mg over mv squared over r, giving us gr over v squared. Okay, so now we know that mu equals gr over v squared, but the speed that we are given here is in terms of the angular speed. Okay, therefore the speed we are given in the question must be converted to tangential speed, which is v, the one we have in the equation here. Okay, the one we have in this equation. So this v, we need this speed in terms of meters per second. Okay, as you can see, the equation is saying gr over v squared, but in the question we have omega, so we change this omega to v, and if we convert that, we are going to find that the speed v therefore equals 2 pi r times omega. Okay, giving us when you square that, it's going to give us 9.43 meters per second. Okay, just forgot something here. Okay, so if we square that, we are going to have we square that, square root. Okay, yeah, something like this. Okay, yes, so v squared therefore is giving us 9.43 meters per second, and if we substitute this value into mu equals gr over v squared, we are going to get our coefficient as 0.28. Okay, getting our coefficient as 0.28. all right, so we go to question 9. Question 9, we have this circular path inside the funnel. Okay, the surface of the funnel is frictionless, as they say. So we need to find the speed at which the particle must move in terms of r. Is it r? If it's to execute this motion. Okay, so we must find the speed in terms of r and theta. Okay, so yeah, that should be theta there. Okay, so we have this funnel. Okay, we have this funnel and a particle, so the weight is acting along that line. Centripetal force, of course, is always acting towards the center of the path, but the funnel, as you may see, is going that way, so its normal force, the normal force acting on this object must be perpendicular to the surface of the funnel. Okay, to this surface of the funnel. Okay, so meaning the normal force is going in that direction. Okay, there. Okay, so if this is the case, then we can have cos theta giving us centripetal force over the normal force, or the normal force cos theta equals centripetal force, and sin theta gives us mg over normal force, or normal force sin theta equals mg. Okay, so since we are finding the speed in terms of r and theta, we divide equation, or rather the second equation, by the first, and we're going to get tan theta giving us rg over v squared. Okay, so we express v in terms of r and theta. We have v equals rg over tan theta, that is v squared. Then we have v being equal to the square root of that. Okay, so we have expressed our speed in terms of the radius as well as the angular displacement. Okay, so here is just an expression for v that they wanted. There's nothing so difficult. We're just expressing v in terms of r and theta. All right, then question 10. question 10. Those doing physics 10, 15. Here you are given almost everything. You only have to find the angular speed. So we know the centripetal force, which is given, okay, which is acting on it as it settles out of the plasma. So that is the centripetal force given as mv squared over r. So we find an expression for v first. Okay, so v squared equals centripetal force times radius over m, and v equals fcr, equals the square root of fcr over m. So we are going to find this v, the speed, and once we have found the speed, we convert this speed to revolutions per second. Okay, we're going to find the speed in terms of meters per second. After we do that, we find, or rather we convert this speed to revolutions per second. Okay, because the question is saying at how many revolutions per second should the centrifuge operate. Okay, so you find v first and then convert that v to omega. Okay, all right, so yeah, until next time, we're done. If you have any questions, further clarification can be provided to you through Telegram or WhatsApp. Simply send your question. Where you are not clear, I will help you. Okay.